yesterday. Okay, can you able to see the screen? Someone 105. Please mute yourself so that we can avoid the disturbance. Now, I am going with the previous explanations. Let us see what we had explained in the previous classes. Now, we started with the scalars and vectors. Now, there we defined what is a scalar with some examples. Okay. Next, we had seen about the vectors. Okay. Now, what is a vector? What is a law that should be obeyed by the vector? Okay, physical quantities having magnitude and direction, they have to obey the parallelogram law of addition. Now, the examples for the vector quantities. Now, thereafter, we had seen the addition of vectors. Okay. Now, thereafter, we went with the subtraction of vectors. Okay. Now, the next topic we covered as the resolution of vectors. Now, under this, we had taken particular vector here. Now, there we had got two components, ax component and ay component. Okay, a component along x-axis and a component along y-axis. Now, components means what is the intercept? If you project a p here from p, if you project onto the x-axis, what is the intercept? Okay, that will be the x component of that particular vector a. Okay, similarly, if you project point p onto the y-axis, where is the intercept? Okay, then that will be the magnitude of or the component of this particular vector. Okay, so here it is having a magnitude, the length of the vector you can obtain here, and the direction is along the y-axis. So this component will have both the values. It will be having the magnitude as well as the direction. What is the direction here? It is along the y-axis. Similarly, ax will have the magnitude from this point to this point, okay, between these 2 points. And here it will be defined only on the x-axis. Okay, it is projected towards the x-axis. Okay, so these two are the components of the vector a in this particular example. Now, thereafter, we had seen the resultant vector a. Resultant vector a can be given as the sum of these two components. Okay, the sum of these two components, x component and y component. And thereafter, we had given I cap, j cap as the unit vectors. Okay, now I cap will be on the x-axis and j cap will be on the y-axis. Okay, now we are going to use these two, I cap and j cap, and we are going to give the components in terms of I and j. Okay, now here x-axis, along x-axis we are getting I cap. So here this gives the direction. What is the direction here? It represents, I represents along x-axis. Okay, so this is the direction and this is the magnitude. Ax is the magnitude. So ax is a vector, okay, which is a component of the vector a, okay, which can be given as ax I cap. Similarly, the y component will be having a magnitude ay and the direction is defined along y-axis. So we are marking this as j cap. So there is no value, but this gives only the direction. Okay, this gives only the direction here. So that we had substituted in this equation. So a is given as x component plus y component. And here in terms of I cap and j cap, we had substituted here. Now thereafter we had given the values in terms of theta. Okay, taking the trigonometry. Okay, x can be given as the hypotenuse into cos theta. So hypotenuse value is a. If you can go with the diagram, if you go with the diagram, this diagram. So this is a triangle here. This is a triangle. Okay. Now here x component. This is x component, which can be given as hypotenuse into cos theta. Okay, cos of this angle theta. Similarly, y component. Okay, this value, and this value are equal. Okay, so either you can refer this diagram or this diagram. Okay, better to refer this. Okay, because we are referring this triangle. Okay, now depending on this triangle, this component will be ay. Okay, so this can be given as hypotenuse into sine of theta. Okay, so that's why you are getting two values, x component as hypotenuse a into cos theta if you consider the triangle. Okay, similarly in the y component here it is given as a into sine theta. So now here the magnitude of a vector a can be given as under root ax square plus ay square. Similar to your previous explanations regarding trigonometry, the hypotenuse value r can be given as under root x square plus y square. Okay, the same thing here. We had substituted this as x component, this as y component. Okay, this is the resultant vector. Now theta in terms of tan theta. Tan theta can be given as sin theta by cos theta. If you substitute those things, you are going to get y component by x component. Okay, the same thing we had substituted here. Now if you want, you can substitute these two equations. Okay, so ay is nothing but a sin theta. Okay, divided by ax means a cos theta. If you substitute that, a will get cancelled. Then what it will be? It will remain as sin theta by cos theta. So that is the tan theta. Okay. So here tan theta is nothing but the y component minus x component. Let me check here. Okay. Now the next topic we had the transformation of scalars and vectors under rotation. Okay. So this topic will have two parts. In the first part, you will explain about the scalars, and the second part will be regarding the vectors. Okay. So the concept should be under rotation. Okay. Now here, if you go with the scalars explanation, transformation of scalars. Okay. Now there you can refer these two diagrams. Okay. Now here what we had explained previously. So this is the XY frame. Thereafter we got XY frame, and here this has X dash Y dash frame. Okay. Now under this what you got the explanation, the scalar quantity. This is a scalar quantity. It is remaining same. Okay. The length between or the distance between these 2 points is remaining same. Okay. Even though you followed a second path, the result is remaining same. So the scalar value is remaining same. So that's why what you had concluded in the first part, you concluded that the scalar quantity, this is the conclusion, you concluded that scalar quantity remains unchanged when we observe from the rotated frames. Now, what is the second part? Second part is about the vector quantity. Okay. So what happens to the vector quantity under rotation? Okay. So here the result is nothing but it is going to change. In the case of scalar, what we concluded, it is remaining unchanged. So the scalar quantity will remain unchanged, but in case of vector quantity, we are going to get a change. Okay, so that particular change we had explained with these diagrams. Okay, so for that we had considered the same diagram. Okay, so xy frame and here x dash y dash frame, and we had considered a single vector a, and we had considered the projections. Okay, and thereafter we had calculated with simple mathematics. Okay, so we had used the trigonometry. Now depending on the trigonometry we got x dash component. Okay, x dash and thereafter we got the second component as y dash. So this is regarding the x component here. Whatever you are seeing, it is about the x component. Now the diagram is, this particular diagram is for calculating the x dash component or x dash. Okay, so what is x dash here? X dash is the distance between point O and point B. Okay, so what is x dash? It is a projection of A. Okay, this particular A is only a point here, but actually you refer to the vector here. Okay, refer to the vector. This particular end point of this particular vector. Okay, this particular point is projected onto this x dash or x there, the second frame. So this particular length is nothing but x dash. So that we had obtained here using the simple geometry or the trigonometry. Now we got the values. Okay, we had used the triangles, whatever we got the projections. Now thereafter you got x dash component as x cos theta, and it is the sum of these two components. Okay, x dash can be given as x cos theta plus y sin theta. So this is regarding the x dash component. Okay, or x dash. Okay, now regarding y dash, we had changed the projections to avoid confusion. So we had redrawn the same diagram, Okay, we got a vector here. Okay, and here these are the two frames. Red color marking is second frame, and black color marking is regarding the first frame. So to get the value of y dash, we are considering this diagram. Okay, we had redrawn the diagram with certain other projections. Okay, the diagram can be used to obtain the y dash component. So again here we had applied the trigonometrical formula, and we got the value. Okay, we got the y dash value. Okay, as sum of minus x sin theta plus y cos theta. So these things we had seen in the earlier classes. Now here what was the point that is to obtain here means you need to obtain the x dash component of A, okay, and y dash component of A. So we had converted this equation, into this. So what is the change here? Just simply substitute x dash as A x dash. Okay, next x as ax. Okay, these are the suffixes here, just like a1, a2, a3. These are the suffixes. Okay, now instead of y you are going to substitute ay. Okay, now similarly you substitute ay dash in this particular equation, and you convert all these components. Okay, then you are going to get this equation or these equations. Okay, now the first equation gives the x component of ax in xy frame, x dash frame. Okay, similarly this is the y component of a in y dash frame. Okay, now what is the conclusion of this topic means here these components are having certain different values. Okay, so that's why we can conclude that the values of a vector in a frame which is rotated with an angle theta are going to change. Okay, that is a conclusion here. Now the point of observation, we are referring here x dash and y dash. What happens to the z dash? That will be a question. You may erase this question. What happens to z dash if you consider 3 dimensions? So here we are not considering the change in the third direction. The third direction is remaining as it is. Okay, so how you are getting this compound, this particular thing, why these two are unchanged means I had given one example. So let me give one more time. So what was the explanation? Now here you take two papers. You take two papers like this. Okay, first paper is in black color. Second paper, let us take this as some red color. Okay, now second paper is there. Second paper is also there. So now here in this diagram, both are there concentrating on the same point. Now consider this as the x-axis of both the papers, and this has a y-axis for the both the papers. Now here it is 90 degrees. Now where is the third axis? This will be the third axis. Okay, this is the first case without any rotation. So this is the z-axis. Okay. Now what is the second case? We had moved a paper. Let us take another diagram. Now I will read rather diagram. So first paper is remaining as it is. First paper is remaining as it is. Okay. Now what happens to the second paper? We had rotated the second paper. Okay, we had rotated here. Let us take a rough diagram. Now let me do like this. Somewhat I'm moving in another direction, don't worry, you just consider the point of consideration. So I had moved the paper here somewhat in other direction. Okay, now this is a movement of second paper, but here the z-axis is remaining same. I didn't move anything regarding z-axis. Okay, so now here this black dot, let us make this as black dot. Now here, so this is x, this is y, this is y. Okay, this is y. And where is x dash? Where is x dash? So if you go with this, this is x dash. Okay, now where is y dash? This is y dash. This particular point is y dash. Okay, I had moved in another direction. Okay, so what is the angle? So this is the angle between these two. Angle between x and x dash. This is theta. Okay, I moved in this direction. I moved in this particular rotation. I had rotated in this direction. In the previous case, if you observe, if this is a x, if this is x, and if this is y, okay, we got x dash. We got x dash here, and here we got y dash. Okay, now this is y. Now in the previous case, we had rotated these two in this direction as theta. Okay, now just to get the concept, I had moved the paper in another direction. So the in the real time applications, it may rotate in any one of the direction. So that's why I had taken the second example with with the other angle here. Okay, now this is the thing you need to consider. So the question is regarding z-axis. So z-axis has not changed anything. There is no change in regarding the z-axis. So that's why the component of z will remain as it is. Okay, so there is no change regarding the z-axis. So that's the thing we had concluded in the topic. Okay, so here this is the thing. Az component and az dash component are remaining same. Okay, so what is the thing conclusion here? It is to be noted that z-axis is not changed as xy frame is rotated about the z-axis through an angle theta to obtain x dash y dash frame. Okay, so that was the conclusion regarding vector. Now what is the conclusion of the entire topic? You are concluding here with 2 points. What are the 2 points? The first point is regarding the scalar quantity. So what is the conclusion here? A scalar quantity is specified by a number. Okay, it is having only magnitude. So we are specifying it by a number. So which remains same in the two different frames, even though we got rotation here. Okay, it is, I will repeat here, a scalar quantity is specified by a number which remains same in the two different frames rotated with respect to each other. Now what is the conclusion regarding vector quantity? It is specified by its components. Okay, now regarding scalar, it is represented by number, but in the case of vector quantity, we are going to have the specification by its components. Okay, components along x, y, and z axis respectively. Okay, when it is seen from a frame rotated with respect to the original frame. Okay, so that is a conclusion regarding the previous explanation where we had ended. Okay, now if you are having any doubts, you can raise your hands so that I can unmute. If you are having any doubts, you can raise your hand regarding the topics whatever we had covered till now. Okay, someone raised here 131. Okay, 131, you can unmute, and if you are having anything, you can ask me. And similarly, 103. I had unmuted from
హలో
my
సార్.
side.
హలో
Okay, okay. Good
సార్,
afternoon.
స్కేలార్ క్వాంటిటీ అన్చేంజ్డ్ కదా సార్?
Mm-hmm.
దానికి రీజన్ ఏంటి సార్? ఎందుకు చేంజ్ కాదు సార్ అది?
ఎందుకు చేంజ్ కాదు అనేదానికి మీకు ఒక ఎక్స్ప్లెనేషన్ ఈ పర్టికులర్ ఎగ్జాంపుల్లో మీకు ఇచ్చాము ఇక్కడ పైకి ఒక నిమిషం. ఓకే, నౌ లెట్ us see here. So this example, okay, let me repeat one more time. Okay, now here I will take a diagram here. Now this is a diagram. Now what was the thing? This is a vector here. I am drawing a vector here. Okay, now this was the vector. Let us take this as a vector A. Okay, now we are going to explain about the scalar, so I need to remove this as a vector. Okay, explaining about the scalar. Now let us take another example, another explanation actually. Okay, with the same diagram. Now here what was the thing I had explained previously means, you consider that you are moving from point O or the origin, and you moved from certain distance, some 800 meters along x-axis. Up to 800 meters you moved along x-axis. Okay, from there you had diverted your direction and you moved certain distance of some 600 kilometers. Okay, 600 meters. Okay, now you ended at this particular point. Now if you take the vector, actually the question is arising, why you are considering only this particular direction. If I ask a question, then the answer will be like this: this is the shortest distance between the starting point and the ending point. So some other person may move like this, somewhat like this, somewhat like this, but actually you need to consider the starting point and the ending point, and you have to take the shortest distance whatever the thing is available. Okay, now here if you go with the geometry, you will get around 1000 meters. Okay, if you take the geometry, so here how can you get the geometry? If r is a hypotenuse, then you are going to get this as x square plus y square. Now what is x? Here x equals to 800. What is y? Y equals to 600. If you substitute these two values, then you will get this r as 1000. Okay, which is nothing but how you got means, you are taking the 800 square. Okay, the value whatever you had moved along x-axis, and you are taking the value around 600 here whatever you had moved along y-axis. If you take this particular concept, you are going to get the result as 1000 meters. What is the 1000 meters? It is the shortest distance from point O to point P, or the starting point to the ending point. Now this is regarding the xy frame. Suppose if we had moved 800 meters in x direction and 600 meters, and thereafter you reach this point. Now second person is there, some other person is there. He may follow another direction. Okay, he may not follow your direction. Then what you are explaining here, you will take this particular diagram. What is the diagram? First you mark the previous point. Okay, mark your values, okay. Now here this is your path. You moved in this direction, and you moved in this direction, and you reached the end point, point O to point P. Now you mark this as the xy frame, your frame. Okay, now second person is there. He is going to move in another path like this. Okay, in this particular direction, which is marking as x dash here. Now he moved certain distance, okay, up to this particular point, and he reached here in this direction. Okay, he diverted in this direction and in this direction, and he reached here. Now here if you mark 800 as x component, and for the second person you cannot mark x here, you need to mark some x1 or x2. So instead of x1 or x2, I had marked this as x dash. Now this particular value as y for your value. Now here I'm marking this as y dash. Okay, some other value. Okay, So here, but actually, what is the concept remaining here? You had moved some 1,000 meters, okay, and you reached here. Now, what is the distance traveled by this particular person? Again, the point is remaining same. Okay, the distance between the 2 points is remaining same. Is it right or not? Okay, so here the starting point and ending point of the first case and the second case are remaining same. So that's why the scalar quantity, the scalar quantity, okay, the distance between these 2 points, starting point and ending point, is remaining as 1,000 meters as it is in both the cases. It is not changing. Okay, even though you moved in the x y frame, and if the second person is moving in the x dash y dash frame, the result is remaining same. The distance between the 2 points is remaining same. So the distance is considered as the scalar quantity. So that's why the scalar quantity is unchanged even the frames are rotated with an angle theta. Okay, so that is the concept. Okay, అర్థమైందమ్మా?
Okay, sir.
Okay. Now any other thing? Say 131, I think. 131, I had unmuted you. 101, I had unmuted you. 131. Any more doubts? If anyone is having doubts, you can raise your hands. Okay, now let us go with the next topic. Okay, I will give the introduction with some small video. Okay, now what is the topic we are going to see? Okay, now here we are going to see about the types of forces. Okay, next topics, the upcoming topics are types of forces. Okay, or else the topic will be like this. You will get a topic like this in your syllabus. It is mentioned as forces in nature. Forces in nature, that is a topic actually mentioned in your syllabus. Okay, now the next topic will be regarding Newton's laws. Okay, now let us
Sir,
see the
new chapter అందులోనే కంటిన్యూ సార్.
ఏంటమ్మా ఏంటమ్మా
సార్ న్యూ చాప్టర్ అందులోనే కంటిన్యూనా?
లేదు అందులోనే నెక్స్ట్ టాపిక్
ఓకే.
Okay, now here what actually you had learned in your previous studies, that let us cover here. Now I will play a video. Try to observe what you had studied in your earlier cases. Okay, I will play a short video. Okay, we are seeing about force here. Okay, we are seeing about the force. What actually force is? First, you need to know what is the force. Okay, now I will play. Okay, force is nothing but a push or pull. Now let us see what is going on here. Okay, these are the examples. You can observe the examples. So this person is hammering a nail here. Okay, so this is a wood here. On the wood, he is hammering a nail. So he is trying to apply the force here. So what actually here? He is trying to push this nail inside this particular wooden or whatever the thing is there. Okay. Now other examples. Let us see the other examples. Okay, second example is this. Some object is there,
Pull.
is trying to pull. Okay, so here push or pull, these are the things you need to consider as the force here. So let us see the other things. Okay, this is about our daily life. So we are trying to pull the objects or pushing the objects in these examples. So these things are explaining about the importance of the force and what is the force actually. Okay, someone is unmuted. Try to mute yourself. I am getting some disturbance. Please mute yourself. Okay, let us continue here. So here, what is the thing you need to observe? Force is nothing but pushing or pulling. Okay, that is the thing you need to observe here. Okay, now here the effects of force. What happens if you are pulling or pushing? Okay, that is the thing about this. Okay, you are going to get 5 different things. Okay, now with an example, what it is going to do? The force is going to give a motion here. So this is a stationary object, a football here. If you apply the force, what happens? Okay, as you had applied a force, the stationary football has moved certain distance. Okay, initially the football was here at rest here. So as you had applied a force, it has moved to certain distance here. So it will have a change in the rest and it will have a motion due to the application of force. Okay, now here the moving objects can also be stopped. Okay, how a football and this particular goalkeeper is stopping here because he is exerting some force. Okay, in the first case, the ball was actually at rest. So as you are applying the force, it has moved. Okay, so you are creating a motion here. Now here a moving object is there that you are going to stop. Okay, this particular force is applied, so that's why you are going to stop the moving object. Okay, those are some of the examples regarding the force. Okay, now in your previous knowledge, we had explained some different types of forces. Okay, so that was the what the in the this particular video. It explains about the what actually force is there. So what happens to the things regarding the force. Okay, now let us see the things regarding the forces, the types of forces. We can consider these as the types of forces. Okay, now let us see the topic as types of forces. Okay, types of forces in nature. Okay, now what actually force here? Force is nothing but a, it is nothing but a push or pull. Okay, now here according to your previous studies, you got some 4 types of forces. We are having 4 different types of forces. What are those 4 forces? Let us take another color here. Now the first thing is about the gravitational force. Gravitational force. Okay, next the second one is electromagnetic force. Electromagnetic force. Okay, now third thing is about strong nuclear force. Nuclear force. Okay, next the last one is weak nuclear force. Weak nuclear force. So these are the four types of forces basically we are going to define. Define in the sense, these are the types that we can classify. Okay, the entire forces can be classified into these four types of forces. Okay, so you might have studied about gravitational force, electromagnetic force, and here these nuclear forces are defined regarding the atoms. Okay, that we will see in the upcoming classes. Okay, one class I will spare for these particular things. Okay, now uh, the next topic is regarding the Newton's laws. So Newton laws, you are having three different types. Okay, so first law, second law, third law. Okay, first law, second law, third law. Okay, so these topics we will cover in the upcoming classes. Okay, let us see. Let me check once again if there is any video with me. I will play that one also. Okay, I will play the video regarding Newton's first law. So don't worry, I will explain the things, whatever the things are required, I will explain in the next upcoming classes. So I'm playing about the Newton's first law. Just you see the video, what is going on with Newton's first law. Okay. Okay. Meanwhile, I will ask a question here. Are you able to listen the voice of the video or not? I'm just confused here. Are you able to hear the voice of the video or not? Just you reply in the chat box. Are you able to hear the voice when I'm playing the video? Voice of that particular video. No. Okay. Someone is saying yes. 112 is saying he can hear. No, sir. Okay. But actually here the sound is maximum here, almost maximum. So there might be a problem regarding the system, I think. So let me give the narration for this. So here the question is there regarding the Newton's first law. Okay, we are seeing a small video. Now a particular person is running. Now suddenly he cannot stop. Okay, it will take certain time. Okay, so that is the thing you can observe. Okay, the question is there, will you can turn immediately towards right if you are running fastly? Okay, then the answer is no. The question is, if you are running fastly, you cannot suddenly turn. Okay, so that is the thing. Okay, similarly you cannot stop all of a sudden. Okay, if you can see one more example, if a running bus is there, okay, inside that bus you are there. So suddenly you cannot jump from that particular bus. You need to run through that particular bus. Okay, thereafter only you can stop. So this particular thing that was explained here. Okay, similarly here with some football here. Okay, this particular ball is at rest here. So here rest means there is no velocity, zero. Okay, so that is the thing explained. Now here considering a football is there moving with some velocity 2 meters per second. So this particular football is at rest here. The first football is at rest. and second football is there moving with some constant velocity 2 meters per second. Okay, now this particular football is there at rest. Now why it is at rest? Because it is having two different forces here. A force is pulling, the gravitational force try to pull towards the downward direction, and the normal force we consider as it is pulling in the opposite direction. So both these two, normal force and the gravitational force, both are acting at a time, and the values of these two are same. So that's why this football remain at rest. Okay, now let us continue. Now, regarding the football, if it is moving with some 2 meters velocity, 2 meters per second velocity, it will continue with that particular speed. Okay, now the question arises, how can you move this particular football? By exerting a force which is unbalanced, okay, that we will see later on what is unbalanced and what is balanced. So think that a force should be there that should act on the football, then only this football moves from rest position to some moving position. Okay, so it is going to accelerate. Okay, whenever you are going to apply a force here, which force is unbalanced here. We will see about balanced and unbalanced in the next videos or the next explanations. Okay, now here a football is there. We consider the second football. It is moving with some constant velocity. If you want to change from 2 meters to 3 meters, nothing but the speed should be increased in this particular case. If suppose if you want to increase the speed of the football, moving football, you need to apply a force, okay, in the same direction whatever the thing is moving. Okay, in this direction if you apply a force here, what happens? The speed of the football will increase. So what is the thing you need to consider? The rest, the football at rest, if you want to move you need to apply a force, and a body which is there which is moving, if you want to increase the speed, then also you need to apply a force. Okay, this gives the Newton's first law. Now let us see what is the definition previously you had studied. Okay, now here this is the definition. Okay, now what is the first law that was explained? Newton's first law can be defined as an object at rest. Okay, it will stay at rest, and an object in motion stays in motion. Okay, with same speed and same direction. If the body is moving with some velocity, it will continue with that speed and same direction up to which time, unless it is acted upon by an unbalanced force. Okay, that is the thing you need to define here. So here what was the example we had seen here? Depending on this, if the body is at rest, it will remain as it is. If a body is in motion, it will remain as it is. Okay, unless you are applying a force which is unbalanced force, then only this object or this object will changes. Okay, that is the thing you need to observe regarding the definition. So that, okay, now let us see the definition once again. Okay, an object at rest stays at rest, okay, as it is. Okay, next, an object in motion stays in motion with same speed and same direction unless acted upon by an unbalanced force. So that gives the Newton's first law. Okay, now these things we are going to see in the upcoming classes.
హలో,
Yes. Who is that?
అన్బ్యాలెన్స్డ్ ఫోర్స్ అంటే ఏంటి సార్?
That's what I am saying. I will explain about these things in the upcoming classes. You don't worry about those things. I will give
ఓకే
the
సార్.
difference between balanced force and unbalanced force.
ఓకే.
No, here something is there. Okay, any other student, if you are having any doubts till now, after the yesterday's class, you can ask me. So another 10 minutes, 9 minutes time is there. So I would like to utilize this as a doubts clearance session. Now, the thing is that you need to learn the concepts. మీరు ఇంటర్మీడియట్లో టెన్త్లో ఏదైతే చదివారో ఆ ప్రాసెస్లో ఇక్కడ ఉండకూడదు. ఇఫ్ యూ వాంట్ టు బికమ్ ఏ గుడ్ ఇంజనీర్, యూ నీడ్ టు లెర్న్ ఇన్ ఎ డిఫరెంట్ ప్రాసెస్. ఇంటరాక్ట్ అవ్వాలి, సబ్జెక్ట్ కూడా నేర్చుకోవాలి. సబ్జెక్ట్ ఏదైనా ఉంటే దానికి అసలు ఏంటి కాన్సెప్ట్ ఏంటి అనేది నేర్చుకోవాలి. నేర్చుకుంటేనే మీకు యూజ్ ఉంటుంది. ఇంటర్మీడియట్లో లాగా 900 స్కోరింగ్ రావాలి, 800 రావాలి, 99 రావాలి అనేది కాకుండా సబ్జెక్ట్ ఎంత నేర్చుకుంటున్నాము అనేది మీరు దాని మీద కాన్సన్ట్రేట్ చేయాలి. ఓకే, అటెండెన్స్ కోసం మార్క్స్ కోసం కాకుండా సబ్జెక్ట్ మనం ఎంత నేర్చుకున్నాము దాన్ని బట్టే మీకు అప్కమింగ్ ఏదైతే మీకు జాబ్ పర్పస్కి వెళ్ళినప్పుడు మీకు యూస్ అయ్యే థింగ్స్ అంతా కూడా ఇంటరాక్టివ్ లెర్నింగ్లోనే ఉంటుంది అనమాట. ఓకే, సో కాన్సన్ట్రేట్ ఆన్ ద సబ్జెక్ట్. ఓకే, సబ్జెక్ట్ ఇన్ ద సెన్స్ ఆ టాపిక్ ఏంటి, అది ఎందుకు నేర్చుకుంటున్నాము, ఏం నేర్చుకుంటున్నాము అనేది కావాలి అనమాట. సో someone 112 I had unmuted you. If you want to speak anything, you can speak. 112. Roll number 112. I had unmuted you.
హలో సార్.
ఓకే, గుడ్ ఆఫ్టర్నూన్ అమ్మా, చెప్పమ్మా. వాయిస్ బ్రేక్ అయింది నీది. వన్ వన్ టూ వాయిస్ బ్రేక్ అయింది.
సార్,
ఓకే, చెప్పమ్మా. ఎవరు?
ఏమైనా ప్రాబ్లం ఉంటే
ఒక్క నిమిషం. వాయిస్ ని తక్కువ వినిపించట్లేదు, నీ వాయిస్ వినిపించట్లేదు.
ఏమైనా ప్రాబ్లం ఉంటే పర్సనల్ గా అడగచ్చు సార్ అంటున్నా.
ఓకే, ఏది ఏం ప్రాబ్లం అనేది కూడా నాకు కరెక్ట్గా మెన్షన్ చేయండి. తర్వాత అయినా ఫోన్ కాల్ చేయండి. ఆఫ్టర్ 5:30కి ఒకసారి చేయొచ్చు మీరు. 5:30కి.
ఓకే
ఓకే ఓకే ఓకే. ఇంకా ఎవరైనా? ఓకే, నో ప్రాబ్లం. ఓకే, ఇంకెవరైనా హ్యాండ్ రైజ్ చేస్తే ఐ విల్ అన్మ్యూట్.
హలో,
ఎస్, హూ ఇస్ దట్?
సార్ ఒకసారి ట్రాన్స్ఫర్మేషన్ ఆఫ్ వెక్టర్స్ లో ఒకసారి మెయిన్ పాయింట్ లో చెప్పండి సార్. ఆ డయాగ్రామ్ ఒకసారి ఎక్స్ప్లెయిన్ చేయండి సార్.
ఏంటిది?
వెక్టర్స్ అండర్
ట్రాన్స్ఫర్మేషన్ ఆఫ్
రొటేషన్. వెక్టర్స్ అండర్ రొటేషన్ లో
మీరు అడగకుండానే నేను స్టార్ట్ చేసి ముందు ఎక్స్ప్లెయిన్ చేశాను నేను. వెక్టర్స్ అండర్ రొటేషన్ లో ఇది అందుకే నేను ముందు ఫస్ట్ ప్రీవియస్ టాపిక్స్ ఏంటి అనేది ఎక్స్ప్లెయిన్ చేశాను. చెప్పు, దీంట్లో ఏంటి డౌట్?
ఒకసారి డయాగ్రామ్ కన్ఫ్యూజ్ అవుతాను.
డయాగ్రామ్ కన్ఫ్యూజన్ ఉందా? ఏ ఫస్ట్ డయాగ్రామా, ఇది ఈ డయాగ్రామా, ఇప్పుడు వచ్చిన డయాగ్రామా? రెండు ఉన్నాయి కదా. ఎక్స్ డాష్ కాంపోనెంట్ దా ఏంటది
సార్? ఒకసారి ఎక్స్ డాష్ చేయాలి, ప్లస్ రెండు కేసులు చేయాలి సార్. ఇది
రెండు ఉంటాయి, రెండు డయాగ్రామ్స్ ఉన్నాయి కదా. ఫస్ట్
ఎక్స్
డయాగ్రామ్
డాష్
ఏమో ఎక్స్
ఎక్స్
డాష్.
ఒకటి, ఎక్స్ డాష్ ఒకటి.
ఎక్స్ డాష్ ది ఫస్ట్ డయాగ్రామ్, వెక్టర్స్ కి
X
వెళ్ళారు
dash
కదా,
కి ఫస్ట్
ఫస్ట్ డయాగ్రామ్ ఉంది
అది
కదా,
కాదు సార్ వెక్టార్ లో అనేది వెక్టార్ లో.
ఇది ఇప్పుడు నువ్వు ట్రాన్స్ఫర్మేషన్ ఆఫ్ వెక్టర్ అన్నావు కదా.
అవును.
ట్రాన్స్ఫర్మేషన్ ఆఫ్ వెక్టర్ దాంట్లో 2 డయాగ్రామ్స్ ఉన్నాయి కదా.
ఓకే.
ఇప్పుడు నీ డిస్ప్లే చేసాను చూసావా, స్క్రీన్ మీద ఏమొచ్చింది చూడు.
అవును సార్ చూసిన.
ఓకే, ఇదేనా నువ్వు అడిగిన కాన్సెప్ట్?
అవును.
ఓకే, ఇప్పుడు ఏదైతే డిస్ప్లేలో నీకు కనబడుతుందో ఇది ఎక్స్ డాష్ కాంపోనెంట్ కి డిరైవేషన్ కి ఈ డయాగ్రామ్ యూస్ చేయాలి. ఎక్స్ డాష్ కాంపోనెంట్ కి ఈ డయాగ్రామ్. సెకండ్ డయాగ్రామ్ ఉంది కంటిన్యూషన్ లో, ఇగో ఇప్పుడు డిస్ప్లే వస్తే చూడు. ఓకే, ఈ డిస్ప్లేలో వచ్చింది వై డాష్ కాంపోనెంట్ కి ఈ డయాగ్రామ్ యూటిలైజ్ చేయండి. అంటే అందులోనే ఫస్ట్ డయాగ్రామ్ లో గీయొచ్చు, ఇదంతా గీయొచ్చు, కాకపోతే కన్ఫ్యూజన్ గా ఉంటుందని మీ ఏదైతే అవసరమో అంతవరకే గీసాం అనమాట. దీంట్లో రెండు
ఒకటి
సేమ్,
ఎక్స్ డాష్ కేసు, వై డాష్ కేసు.
వై డాష్, ఇదేం వై డాష్ కోసం అనమాట అట్లా.
ఓకే సార్.
ఓకే ఓకే ఓకే. నెక్స్ట్ 162, ఐఎమ్ అన్మ్యూటింగ్ యూ. నెక్స్ట్ ఓకే 162 I had unmuted.
సార్ గుడ్ ఆఫ్టర్నూన్ సార్.
గుడ్ ఆఫ్టర్నూన్, చెప్పమ్మా.
సార్ ఇప్పుడు నోట్స్ అంతా మాకు వాట్సాప్ లో పెట్టారు సార్.
వాట్సాప్ లో ఆల్రెడీ నిన్ననే షేర్ చేశాం కదా. వాట్సాప్ గ్రూప్ లో ఉన్నావా నువ్వు?
ఉన్నాను సార్.
వాట్సాప్ గ్రూప్ ఒకసారి చెక్ చేసుకో, నిన్ననే ఆల్రెడీ షేర్ చేశాను నేను.
ఈ రోజు క్లాస్ కూడా పెట్టలే సార్.
ఈ రోజు ఇంకా నేను అది మొత్తం ప్రిపేర్ చేశాక మళ్ళీ పెడతాను నేను. ఇప్పుడు రన్నింగ్ అయ్యే టాపిక్స్ కి టైం పడుతుంది, ఎందుకంటే ఇది కొత్త సిలబస్ కాబట్టి కొంచెం టైం పడుతుంది నోట్స్ మొత్తం ప్రిపేర్ చేయడానికి.
ఓకే సార్.
ఓకే ఓకే
థ్యాంక్ యూ సార్.
ఓకే, నో ప్రాబ్లం. ఇంకా ఎవరైనా ఉంటే హ్యాండ్ రైజ్ చేయండి, ఐ విల్ అన్మ్యూట్ యూ.
హలో.
చెప్పండి అమ్మా, ఎవరు? గుడ్ ఆఫ్టర్నూన్ అమ్మా, చెప్పు.
సీనియర్ వాళ్ళ
వాయిస్ బ్రేక్ అవుతుంది. 162నా? ఓకే, ఇంకెవరైనా మాట్లాడతారంటే హ్యాండ్ రైజ్ చేయండి. హలో, ఎవరమ్మా, చెప్పండి.
హలో.
చెప్పమ్మా.
సరే, సీనియర్ వాళ్ళ బుక్స్ మాకు
సీనియర్
యూజ్
వాళ్ళ
చేసుకోవచ్చు.
చేయొచ్చు, కాకపోతే దాంట్లో ఓన్లీ ఫస్ట్ మెకానిక్స్ అనేది మాత్రమే మీకు కామన్గా ఉన్నట్టుంది. కామన్గా ఉన్న టాపిక్స్ ఏవైనా తీసుకోండి, నో ప్రాబ్లం. కామన్గా మీకు సిలబస్ ప్రకారం ఉంది అనుకుంటే తీసుకోవచ్చు, నో ప్రాబ్లం.
అంటే
సిలబస్లో కొంచెం చేంజెస్ ఉన్నాయి, సిలబస్ చేంజెస్ అయినాయి. చేంజ్ అయిన టాపిక్స్ వదిలేసి కామన్గా ఉన్న టాపిక్స్ మీరు ఏదైనా రిఫర్ చేయండి, నో ప్రాబ్లం.
ఓకే సార్.
ఓకే. Okay, any more thing? 131. If you want to speak anything, the hand is raised still now. Number 131. If you want to speak anything, I had unmuted from my side.